Good morning, CSEC students. Welcome to another live CSEC class. This morning we're going to be looking at how to solve simultaneous equations using a matrices method. In order to do this, what we do is we find the inverse of the matrix, and then we use the inverse to find the simultaneous equation. So I'm going to show you those steps. So I'm waiting on my students to log on, and then we'll go forward. In the meantime, I'm going to set up my matrix. All right, so let me set up the matrix. Okay. So we would be given the simultaneous equations. So we'd have 3x minus 5y gives negative 13, and negative 2x plus 3y gives 8. All right, so what we'll do is, so that's the original equations, two equations. So we'll first write it in the matrix form. So we'd put the term, so it's 3, negative 5, and negative 2, 3. And we'd multiply that by x, y, and we'd have negative 13, 8. So these two values, we put them out here. All right. So what we're going to do is we're going to find the inverse of this matrix. All right. So find the inverse, and we know the inverse is 1 over the determinant times the adjoint. So that will be 1 over 3 times 3, 1 over the determinant. So A times D minus B times C, that's the determinant. So minus B, which is negative 5, times C, which is negative 2. And that gives, so it's 1 over 9 minus 10. So that's negative 1 over 1, which is negative 1. So 1 over the determinant gives us negative 1. So we're going to multiply this times the adjoint, and the adjoint is, we reverse the A and D, but they are the same thing, so we have to write back the same thing. Change the sign of the B and the C, so it becomes 5 and 2. All right. So what we're going to do now, we're going to write that. So this is the inverse. So it's the inverse. All of this together is the inverse times these two values now. The negative 13, 8 equals x over y. And what we're going to do, you could multiply these two and then work that. So you'd end up with -3, -5, -2, -3, and then multiply that by this. I prefer to leave the 1 over the determinant and work these two first, because many times you end up with a fraction here as 1 over the determinant, and it's easier to work with the whole numbers first and then the fraction, right? So it's a -1 now, but usually from experience you would know 1 over the determinant is usually a fraction. So I'm going to multiply out these two. So I'll have 3 times -13 plus 5 times 8 over 2 times -13 plus 3 times 8 and that is gonna give x, y. And these two should be in bracket. I just don't have any space, right? These two should be in bracket. So simplifying that, I get, so 3 times -13 is -39, and 5 times 8, that's +40. 2 times -13 is -26, and 3 times 8 is +24, equals xy. All right, so simplifying that further, -39 plus 40 is 1, and -26 plus 24 is -2, equals xy. So finally, to get our x and y values, so the top number is the x, so -1 times 1. So x is -1, and -1 times -2 is 2, so y is 2. All right, so x is -1 and y is 2. All right, so let me get some feedback on this. Let me get some feedback. Any questions? We're going to work a few more examples. So the first thing you do is to rewrite the simultaneous equation in matrix form. The 2 is positive. Okay, so Carissa is asking, why is the 2 positive? Because we're multiplying the -1 times -2. And that gives a positive. So the -1 that's in front of the bracket, which was the 1 over the determinant, we got -1. We're multiplying that. All right, Ngozi says she needs to see more examples before she can get a clear understanding. So let's work another example. Step by step. All right, so we know we're gonna need to divide that. So we're given 3x minus 4y equals 7, and 2x plus y equals 12. So that's the original two equations, simultaneous equations. So let's write it in matrix form. All right, so we're going to have 3, 2, -4, 1, and we're going to put xy equals 7, 12. So now it is in matrix form. So we're going to find the inverse of the matrix, which is 1 over the determinant. So find that first, 1 over the determinant. So it will be 3 times 1 minus -4 times 2. And that gives 1 over 3 plus 8, because negative times negative is positive. So that gives 1 over 11. And we're going to multiply that by the adjoint, which is to switch places with the A and D, change the sign of the B and C. All right, so we'll have 1 over the determinant times the adjoint times 7 over 12 equals xy. And I always have no space, but these should be in brackets. So as I said, usually 1 over the determinant will give a fraction. So leave the fraction for last and multiply these two. So 1 times 7 plus 4 times 12 over -2 times 7 plus 3 times 12, and that will give xy. Let me write this 12 properly. So that should be at 12. Okay, so keep your fraction for the last step. 1 times 7 is 7, 4 12s, 48. And -2 times 7 is -14. 3 12s, 36 equals xy. So we're simplifying it now. 7 plus 48, that's 55. And -14 plus 36, that gives 22. So x equals, so 1 over 11 times 55. 11 into 55 goes 5. And 11 into 22 goes 2. So x is 5 and y is 2. All right, so give me some feedback on this set now. Give me some feedback on this set. Is it any clearer to you now? All right, so Carissa is saying okay. How about the other Students. All right, so Carissa got it. How about you, Ngozi? Is it clearer now? We're going to do two more. We're going to do two more, okay? But I just want some feedback on these two so far. Okay. All right, so let's do two more. And remember, simultaneous equations, you plug in. Remember, you plug in your values. So x is 5, y is 2, 3 5s 15, 4 2s 8, 15 minus 8 is 7, 2 5s 10, plus 2 is 12. So you plug in back your values to check that you are correct. All right, so let's do some more. So we have 4x. Let me draw my line. 4x minus 3y equals 13. And negative 5x plus 2y equals negative 18. All right. So let's put it in matrix form. So matrix form. So that would be 4, negative 3, negative 5, 2, xy equals 13, negative 18. Now we're going to find the inverse, which is 1 over the determinant times the adjoint. So 1 over 4 times 2 minus negative 3 times negative 5 which is 1 over 8 minus 15, which is negative 1 over 7. And the adjoint, we switch places with the A and D, change the sign of the B and C. So this is the inverse, and we're going to multiply that by these two values here to find our x and y values. So it's negative 1 over 7 times 2, 3, 5, 4 times 13 over negative 18 equals x, y. Keep your fraction till the last minute. Multiply these two matrices. So that will give 2 times negative 18 plus, 2 times 30, my mistake. 2 times 13 plus 3 times negative 18. And this is going to be equal to xy. I don't have any space, but it's equal to xy. And we'll have 5 times 13 plus 4 times negative 18. All right. So it's negative 1 over 7. 2 times 13 is 26. 3 times negative 18. So 3 eighths, 24. That's negative 54.
Miss?
5 times 13, that's 65. 4 times negative 18, that's 72, I believe. Negative 72. All right, so we have negative 1 over 7. 26 minus 54. All right, so that would be not make a mistake. 26 minus 54, negative 28. And 65 minus 72, negative 7. So negative 1/7 times negative 28. So x will be a positive 4. And negative 1/7 times negative 7. So y would be a positive 1. Let's plug those values back in. Let's plug those values back into the original equations now. So we're saying x is 4, y is 1. So that would be so that would be 4 times 4 is 16 minus 3. Negative 3 times 1 is 3. Negative 3 times 1 is negative 3. So 16 minus 3, that's 13. And negative 5 times 4 is negative 20. And 2 ones 2. So negative 20 plus 2 would give negative 18. All right, so let's have some feedback on that one. All right, so Carissa is saying it's a negative 54. So let me see which one. Negative, yeah, it's a negative 54. See there? 3 times negative 18 give a negative 54. So we have that. So everybody good with that? One more example will do you. One more example will do you, all right? So let's do that one more example then, right? And then you can get some to practice. So let's go, let's do that. All right, so Imani is saying, yes, I got it. So Gozi is saying the 7 is used to multiply the negative 28. So it's actually negative 1/7, right? negative 1/7, and you're multiplying that by the negative 28. So it will be like, it's like you're saying negative 1, look at the top of the board here, negative 1/7 times negative 28 over 1. And so what you're doing is canceling the negative 7 to negative 28, you get a positive 4. That's what you're really doing. So last example, we have 4x plus 3y plus 3y equals 17, and 5x minus 2y equals 4. So let's first find, well, put it in matrix form. Let's put it in matrix form. So that's going to be 4, 3, 5, negative 2, xy, and that's equal to 17, 4. Now we're going to find the inverse, which is 1 over the determinant. So 1 over 4 times negative 2 minus 3 times 5. So that's 1 over negative 8 minus 15. So that's negative 1 over 23. And the adjoint is switch the A and D. So we'll have negative 2, 4. And change the sign of the B and C. So we'll have a negative 3, negative 5. So now we're going to go up to the other side and we're going to put those together now. So it's negative 1 over 23, negative 2, negative 3, negative 5, 4 times 17, 4 equals x, y. And we know you could multiply these two first, but you'd end up with some fractions, and then you go and multiply all of those fractions by this. So I just prefer to remember multiplication is associative. So if we multiply these two first, is the same as multiplying these two first. So I'm going to keep my fractions first. I prefer to work with my whole numbers. It's easier to clean up. So negative 2 times 17 plus negative 3 times 4 equal x, y, and negative 5 times 17 plus 4 times 4. So write this back. So negative 2 times 17 is negative 34. Negative 3 times 4 is negative 12. Negative 5 times 17 is negative 85. And 4 times 4 is 16. So negative 1 over 23. And negative 34 minus 12, so that's negative 46. And negative 85 plus 16, that's negative 69. Equals x and y. And finally, now we can work the fraction. So it's the negative 1 over 23 times negative 46 over 1. So we're canceling the negative 23 and the negative 46. We're going to get a positive 2. And the negative 23 times the negative 1 over 23 times the negative 69. That's going to give us a positive 3. X is 2, y is 3. So let's plug those values here and here. So 4 2 is 8, 3 3 is 9, 8 plus 9, 17, 5 2 is 10, negative 2 times 3 is negative 6, 10 minus 6 gives 4. So we know that we are correct. So how is that? How is that? Good? Feel like you have it down pat now? And let me know if you have any questions. So this is in the corner here. It doesn't look like an X. It's supposed to be an X. All right, so I need bigger space on my screen. Okay, so great. Great. Imani says she got it. Carissa says she got it. Let me hear from the other scholars. I'm going to be giving you some to do on your own now in class. So make sure you got it down. But as always, and Zion says he got it, Jamani says he got it, everybody good to go. If you have any questions, you can post them in the comments at any time, even next year. If you're watching it again next year and you think of something that you say, oh, but how comes that? Okay, Ngozi says she'll know for sure when she practices, but of course. And that's what math is all about. So I'm gonna give you now some work to do on your own so you can test out your skills and see if you really and truly understand.